Okay. Let me check. How many of you now running Raspberry Pi? Good. No, 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 on your laptop. Yeah. You got that? All right. So you can work with me. Julie, did you put up? You already set up the PNC, right? Oh, you didn't set up the PNC on your laptop? Oh, you didn't set it up? Did you set up your Raspberry Pi and also your laptop to talk each other? You did it once or here in this class? At home, not here. If you need help, we can do it after the class. If you stay maybe in 10 minutes. I can set it up so that next time you don't need to bring your monitor, keyboard, mouse, simply as I do, uh, power to the Raspberry Pi, then automatically I can work here and also I can work at home. You don't need to. Unless your router reboots. If your router reboots, usually even if so, your router gives the same IP address to the same MAC address. Because the router has, if your router is a little bit intelligent, smart router, then it manages the tables. So for this MAC address, this IP, although it is a reboot, use the same table. If it's the case, then you can continue to use your Raspberry Pi without having to reconfigurations. Marco,
You would have to give it a static IP address, right?
No, there is a dynamic.
Okay.
Dynamic meaning, therefore, if it is a static,
It's
static means it is you have to subscribe to.
Right.
It should be registered. And yeah, about when I was student, it was cheap.
Mhm.
We pay only a few $100s per month. Static. Now it is very, very expensive because it is limited.
Yeah. There's limited IP address,
Right.
especially IPv4.
Yeah. Okay. Okay. The other one, in midterm exam, is a week after your spring break. Okay. Remy, did I surprise you? Yeah, week after the spring break, which is, I'll give you two options. You can come this on the Monday class morning. I think we will begin maybe 8:30 or 9 o'clock on that day. I'll give you 90-minute test. You can stay maybe 2 hours, but usually when I make a 90-minute test, most of the students finish it 45 minutes. You know what I mean, right? And types of questions are multiple choice. Therefore, you can choose. And true, false, which is binary, right? Multiple, 1/4. And short answer, and then filling in the blanks. So 4 types, usually, the question of your midterm. Uh, right now, I'm thinking giving you a paper test. So you don't need to bring, not just you don't need to, you should not. You should not turn on your any digital devices, your cell phone, no cell phone, no uh, Raspberry Pi, no your laptop, but you can bring one page cheat sheet. I'm allowing you to bring your cheat sheet. Okay, there's no limitations, only letter size cheat sheets. Okay, you can write full front and back side. Okay, there's no the font size limit. What else? During midterm exam, you can take a break, go out. But when you go out for long, I want you to leave your cell phone here. Why cell phone is sensitive? Because with the cell phone, you can, I mean, there, and also there is a chat GPT. Chat GPT can help you. And most technical questions, 99% of technical questions can be answered from Chat GPT correctly, from my experience. But Chat GPT, if you ask humanitarian related questions, then it's not really true. For example, if I give two names, real names, friend of mine, I know those two names. So I asked how they are close to each other. Then ChatGPT says always they are so close that they collaborate each and all fake. I do not know why. I know technically because it trained that way, and then replace with those names, although it's not real. But technical questions are accurate. I mean, their answer is accurate.
That's what it's good for.
Yeah, at least, yeah.
Yeah.
Yeah. Right. So that is a major reason that I ask you to come to their the test in person. Um, that way I can maintain the fairness of students' grading, students' assessment. If some students can take, although they hire a proctor, for example, in Pennsylvania, proctor could be librarian. Then librarians are not really proctoring them. They just give the test and they do their own work. Then students has all the network access. Once they have network access, then right. So I tested that last semester. The midterm exam in person, final exam online, and I made it tough questions on the final exams. Most of the students got 95, 99, 100. They got all correct, of course, right? So I cannot make any tough questions that cannot be answered by ChatGPT. If ChatGPT cannot answer, then our students cannot answer either. And I didn't teach that tough questions in this class, right? So almost impossible to have the online exam. So in person, there's no, but it's absolutely in person. Okay, everybody? That's fair to you guys, right? You do not want anybody got full credits while you get 70 points, right? All right. So your midterm exam will cover everything from the beginning till next week class. Not much the materials that we covered, right? We started only last week real Linux commands, and today the basic commands will be done, I think, today, and next week a little bit advanced ones. So we move. Okay, more Linux commands. So I want to revisit IO redirection commands. Output redirection. We have single greater than sign and double greater than sign. If it is a single, then overwrite. If it is a double, then append, right? So you know that. I don't need to really do exercise for this. We done that already. When I type date and one single greater than sign, then the today's date will come into this file, output date. And then if I make a double, then the date will be appended to this. Since the date command, not only the dates, but also timestamps, right? So you may be able to see time elapse. So in this case, maybe 11:14, 20. Yeah, I made this yesterday. 11:14, 20 seconds and 37 seconds. So we have two items. So second one attached to the first ones, as you could see here. That is for the single greater than sign and double greater than sign. We call that output redirection. Okay. There's an input redirection, which is less than sign. So I want to practice a little bit of this together with you. So bring up terminal. Okay, like this. I can push this aside a little bit. Bring this up here. Okay. What's the size of this fonts? Is that okay? A little small, right? So I want to edit to get it maybe 15, 16, 17. Select. This is a 17. Is it 17? Let me check. Bring the other same size. Okay. I think that is because I make this a little bigger. I think this is better. Printf is also works. So if you do manual printf, then it says a format and print data. This looks this like the programming statement, right? Particularly the C language has print. Is it F print? Print. I forgot. Yeah, some languages has print. So this, yeah, this language, this is it the language in most the programming languages. Similarly here in the Linux operating systems. So we can do a print, and then some of the fruits, pear and \n, apple, \n, banana, \n, apple \n, maybe Raspberry Pi, not pi, Raspberry \n, quote. So all of those are in one single string, right? And I want to make the output redirection. Oh, why should I work this here? I want to change it to SP26 ls. I want to make mkdir. Hey, make dir today's dates. So it's 9 March 26. And then I will change it, the directory 9 March 26. And where I am right now, I am under /home /jun /sp26 /9 March 26. So today's lecture will be there. And if I want to do the same, that print statements, then I can see the history of the command that I issued with the number labels. So there is, if I want to redo that printf statements that I made just a minute ago, which is labeled 920. See here, 920. If we want to redo that long typing, long line typing, if you do not want to do it, but redo that once, since you know history with that label number, then you can do exclamation mark and 920. Exclamation means that's the repeat, right? So if we do 920, the exclamation 920, then it will redo that command that I made. Okay, so 920. When I see this, then fruits text just created, right? March 9. The size of that data is 34. Okay, this is timestamps. And I have here the access control bits. This kind of things will be discussed next week. What does this mean? Okay, so we have that. If you want to see that, then we already know. There are many ways that you can see the content. Cat, then you can see all at once. If you want to see page by page, more or less, right? What about echo? Echo fruits.txt. That takes that as a string. So what if we do? Probably not, but let's try. No. Yeah, echo doesn't work. But anyway, cat fruits.txt. Then we can see that. We entered this, right? But we got that. Pear, apple, banana, apple, raspberry. Why that happens? Pear, that's a string. There's no problem at all. In this string, everything is a string, right? When we have string, then when you declare a string with the quote and unquote, then this print command does not evaluate anything within that print, quote and unquote. But if you want something to be evaluated, PAR within quote not evaluated. But as far as something that you want to evaluate it, like this, when it encounter backslash means it's not only here in Linux, but most programming languages, backslash, then it is called the escape character. That is the escape. Okay? What does that mean? So as this printf command scanning this, because this is starting from quote. So, hey, I don't care this. I simply echo it, right? I simply take it as a string, scan this. So when we see backslash, then my operating system, particularly printf command, now see, oh, I want to escape. PAR okay up to this. And when I see this backslash, oh, this is the escape function. What's next? It says N. So backslash N together, it means new line. Okay? So there is a new line. After that, there's no backslash, right? So we keep going. They are part of the string. So PAR, next line, we have a new line. So apple. When it comes to backslash, and that is a new line. So make new line. And the banana, and another new line. After that, apple, new line. After that, Raspberry Pi. After that, new lines. If we do not have this at the end, what happens? Right after this, then my prompt appears here, not in the new lines. My prompt statements in the new lines. Okay, with that, so we know that. What we want to do is the input redirection. So input redirection is this, right? Less than sign. And also we know, let's play with some of the commands. We know WC, right? WC is word count. So it returns new line, how many lines, how many words, and then how many bytes. If we see new WC only. But if you know, if we have an option, for example, -C, then it gives me the byte numbers only. And if we put M, then number of characters, L, number of lines, W, number of words, things like that. So we can try this. WC minus L, then we can see how many lines. So I can, into this command, I want to see fruit.txt. I want to give these files to this command. That's what I mean by the input direction, right? Input redirection. So how many lines of this? How many lines of data contained in these files? We have 1, 2, 3, 4, 5 lines, right? So enter. Then we have 5 lines. Here we didn't have the Raspberry Pi, so we have 4 lines. And we can also sort them. Oh, by the way, we can do simply if we do not have any the options for WC, then we can get all those three numbers. So first number is number of lines, second number is number of words, still 5 words. How many characters or bytes? 34 bytes long. Sort. We can make a sort. We understand the sort command from the manual. So sort, then sort lines of text files. So there is an option B for ignore leading blanks if there is some leading blanks. In this case, we have all okay, right? They are all lined up. Dictionary order. Random sort, numeric sort, minus n, numeric sort. There is a reverse also. Reverse, not ascending order, but descending, then minus r. Right. So we can do sort. We can give a fruit. Right now, what is the order? Pear, apple, banana, apple, raspberry Pi. Pear and apple not in order, right? So if we want to make it order, then apple, banana, pear, raspberry Pi. This is the input redirection. So we give a command first, and then followed by the input. The similar things can be done in in the right order, right direction. What that means is that I can do, for example, cat fruit.txt, and then there's a pipe. Pipe will come in the next slides, but you may be able to see that what that means is that I want to cat this all. I want to list the content of these files, and the content of this file will be the input to the next command. For example, WC. So WC wants to some of the operands, some of the data, right? That data will be fed from the previous commands. If we have a vertical bar here, this is pipe. So output of the first command will be fed into the next command. There's a pipelining, right? Exact same thing here. So the same thing can be done. You could do WC less than sign. This is input redirection. You can do like this. But if you want to make this is somehow the second command comes into the first command, right? This is input. This guy is a little bit forward. So first command goes to the second command, which goes to the next command and next command as it flows, right? That is also possible. If you want to make that, then that is a pipe. If it is the case, then this is input redirection. Okay, back to sort. So we make this sort. Okay. Now we realize that there are the duplication. Apple comes twice. Okay. If we want to make it, whatever this, the outcome of this is actually this, right? All of this. That'll be the input to the next command, which is unique. then it'll make it unique. Apple twice, so we want to make it unique. If you want to see the manual, I want to get another terminal here, and the manual, man unique. Then I can see unique report omit repeated lines. And -c then counts how many the prefix lines by the number of occurrences. So -c option gives you the number of occurrences. -d only print to duplicate lines, one for each group. -d, and yeah. So we can use that. For example, this, and then if I want to give -c, so I may be able to see the number of occurrences. So when I do this, then I do have two of apples, one banana, one pear, one Raspberry Pi. What if we do D, then it gives me only some of the duplications item. Duplicated item can be listed. All others, single occurrence, but apple twice. If we want to see, is there any duplications, then you can get this, right? Sometimes this is very useful, right? Like if we want to investigate in forensics, some of the things appears twice or more. So if we want to make it quick, with the option D.
Is there a limit to how many commands you can type?
No.
No limit?
Okay. No. So that is very, very, very useful, right? If you say limit, then there may be a limit in command. There's computer limits, but the language-wise, there is no limit. Okay, now, can you make this all pipe?
You mean
like
in one line?
Like yeah, Marco said, yeah. Rather than using this, the input redirection, so no input redirection, but only pipe is allowed. Then how can you rewrite it?
Well, you take out the lesson sign. Well, you want me to rewrite it the whole thing without using the pipe?
Correct.
That's what you do? Oh. Let me see. Well, you take out the pipe obviously and the lesson, and you just do unique dash with
So first you have to do fruit. If you do this, then that is a data.
Okay.
So that'll be the input to the next one, maybe sort. So if you do this, then there is a sortings, and everything can be piped into unique. Nice. And then make it C, okay, right? So we have two pipes used.
So it's always using the output of the last one? Of the last command?
There's always the directional.
Okay.
So the first one's outcome of the first ones will be the input to the next command.
Okay.
Yeah. Not master direction.
Yeah, it's going
one direction, right? Straightforward.
Which is the third one that you did, and then it's sorted out.
Mm-hmm.
And then it expressed the unique expressions. Mm-hmm. And then it used the last operator, the dash C. Okay, so that's like the order. Okay.
that hits me some of the command section. Okay. Okay. So for example, if I use a cut, field one only. How can I use that? I need to command F, right? F. So I need to do minus F, and then I want to see the first column only. Oh, it doesn't work. Should I say like this? No. Didn't work. What did you say? I'm thinking of the field. Select only those fields. Oh, this is a list. Fields list. In this case, we need the column title. Delimiter. Some of the delimiter needed. Remove selection from each line of files. Remove sections of each line of removed sections. Minus n. Okay. It's not working. Maybe 1, 2. Cut fields numbered from 1. Numbered from 1. Cut numbered from 2. Numbered from 3. Didn't work. Probably this is not really the column cases. Like when you see the originally fruits, this 927. So no, rather than doing, I can make a copy of this. Copy and paste. Okay. What if I do minus all instead of minus? I want to mix minus n and somewhere minus all minus all and some like this. See what happens. And this is fruits 2. So I have 2 files, cat fruits 2.txt. Then I have pair strange. All for, oh, I'm sorry, not all for carriage return. The one that I want to do was tab minus t. My error. Okay. So if I want to do this and cat, yeah, this is what I wanted. So pear, banana, apple, raspberry pie. Pear, where is apple? That disappeared. Pear, apple, banana. Oh, there's a because of the. We still have you know what? This is a all for carriage return. So when it comes here, then it returns. Now it looks okay. Okay. So pear, apple, banana. I want to make it a little better. So banana, I want to make a new lines. Okay. So we have a pear, apple, then we have tab, app, app, and then backslash T means I want to escape. T for tab. I want to make tab to LE like this. And apple here, I have white space. Reason I'm trying to make this, when you sort to that text, then this guy. What about I do unique? They are not unique, right? Of course, they are not unique. Apple and apple. The one that I want to see here, man, unique. There is something I want to ignore white spaces. I see that somewhere. F, I ignore case. S for avoid the comparing first and characters. U, unique. Z, maybe not unique. Man sort. Ignore leading blanks. So minus B. Ignore leading blanks. So if we do minus B here, right. You see the difference between this and that. This is simply sort. This is simply, this is a sort minus B. If we have option minus B, then it's ignore the leading blanks. The order-wise, this white space becomes earlier than alphabet A. That's what it is. Okay. And if we ignore leading blanks, then we simply compare APP, they are the same. And after that, there's a blank. As I said, the blank is earlier than L. So APP space LE comes before APPLE. How do you know what do you mean by that? The order. If you see the ASCII tables, okay. So there is a the alphabet A that in the order that is a 97. the lowercase. Uppercase, that is a 65. And then there is a space. The number of begins before alphabets. This is a space. Space is a 20. Hexa number 20, decimal 32, that is space. Space becomes earlier. That's what it is. I want to change this to a little bit nano. I want to edit it. So like this. And Control O, write out, hit enter, and Control X, and then similar things that I want to do. Actually, yeah, small ones ahead, then capital A. It's not really actually according to that at the ASCII tables, but somehow, yeah, we can test that another. Maybe one per. Yeah, number comes first, and then small character, and cap. Somehow that is the order of this. And then I have here white space. You know why? Because I made it intentionally. I made the white space, one of the lines here. Because of that, that happens. White space. Okay, that is a redirection, less than sign. We can combine less than sign and greater than sign together. Then what happens is that in the middle, there's a command. Before we have a file can be fed into this command, and output of this command will be written into another file. So two files maybe comes together. So like this, sort, we give fruits, this is input, and output is a full sorted. That is possible, right? So we can do make it simple. So sort, fruit, original fruit. Then we have apple, banana, pear, raspberry Pi. And I want to make, this is the output, right? I want to put that output into the file. Then we can make a output redirection. So we can do fruits sorted .txt. Then one more file can be produced. So this is the input file. This is output file. Output file is sorted file. Apple, banana, pear, raspberry Pi. So that is possible. So I make here one question. One line of commands returns this. How can you make this? When I do fruit connected .txt, what command? One line. Give me one line. from this fruit.txt, how can you make this output? Not the output. How can you make this file, fruit connected.txt, which contains 2 apple, 1 banana, 1 pear? If you want to make. So input is this. Yeah, you have to do this fruits.txt, and then you need to make a unique, right? And then you want to make a count. Everything goes into that file, and we call that fruit counted. Okay. So if I ask one line of commands, can you return this for given fruits.txt? Then your answer is sort less than sign fruits.txt pipe unique minus c greater than sign fruit connected.txt can make this possible. So after some of the command here, if we say cat fruit connected.txt, then we will have this output. See if that is the case here. If we hit enter here, oops, not there. Come back here, hit enter, and when I do cat counted, yeah, our Raspberry Pi is extra we entered, right? So this is the command to this type of questions. This type of questions will be maybe the sample of your midterm exam. Right, Chris? Good sample, right? If I said, oh, you will have a fill in the blank type of a question. That is a fill. Or short answer. Yeah, depending upon questionnaires. Any questions?
Yeah, I don't understand why you need the output on the other side of the pipe. Why couldn't you just leave that out?
Because I want to make a count, right? Having this. If I have this, then I will have this output. And the last output redirection is simply output of this will be dumped into that file.
So you essentially created a new file by grabbing that, and it needed a direction.
Mm-hmm.
Okay.
So redirection means output will be written into that file. That's the redirections. That's output redirection.
So when it's the greater sign, it's grabbing it. When it's the less than sign, it's taking it. Something?
Yeah, there's input.
Yeah, it's taking the input,
Mm-hmm.
and then when it's greater, it's creating.
Create, yeah. So write into.
Yeah, writing from
write
the
in,
output.
yeah.
Gotcha.
Any question? Any additional? How many of you now following the way that I here? You follows? You really practice the way, Aaron? Good. Okay, let's move. standard output versus a standard error. There is a standard error. This is output, right? Greater than sign. Number 2 greater than sign, that if you have any error, it goes into that specific error messages only into that files. For example, if you see here ls no. Because that is too long. When you do etc, when you make etc no nothing, what happens? It says no such file or directory, right? If you can combine these two, ls the current, and then no nothing. Then current, wait a minute, ls dot that. Okay, so we do ls and then no nothing. Then it gives me cannot access no nothing, no such files. And then because of this, we have those 4 content, right? Currently, in my current directory, I have 4 contents. This ls command can take not only 1 argument, but could be multiple. Man ls. Then it says a list of directory contents. File, list information about the files. We can put here files. Okay. So I made two. ls, dot means my current directory. And then a slash, no nothing, there's no such directories, right? So I have an error messages first, and then the list of that ls dot. When I do ls dot, then of course I have this, right? According to the ls dot, I have that, and I have the error messages here. So this kind of command gives me both error messages and then the output from that command together. So sometimes you want to see, hey, I want to put the correct case into my one of the file, and then error messages, which is 2 and greater than sign, into error messages, which is handy. So because this command gives me 2 different cases of output. One case is error messages, the other case is good returns, right? So I want to put the good returns into a one file and error messages into another files. Then my redirection is the normal cases is simply greater than sign, and the error cases number 2 and greater than sign. Together, there's no space, number 2. To differentiate from the greater than sign, we put there number 2. So this is nothing but number 1. Number 1 greater than sign. Why should we have a number 1? Simply greater than sign. And then next one is number 2. Okay, that's what happens here. So when I hit enter and see the list, I have therefore current error.txt and the current files.txt. If we want to see that, cat current error, then we see the error messages there, right? And then cat files, the normal cases, then I can see those are the normal cases. Okay. That's very good. For the system administrators, if you want to see, whatever that you want to do, you want to make some logo files, some of the output in, you want to store the outputs for your reports, then you can save the normal result into a separate files from the error result. Are you Yosef? What is your name? Yosef? What is your last name? Oh, you're Gonzalez. Yandel. All right. Yandel. You were here once, right? Snow days. So what happened to your snows? What snows did it to you? Oh, everybody's. Oh, I see. I was not asking about your snow days. I thought your own snow days. Okay. Let's move. So we have the other one. We might have %0 and %1. Number 2, this is okay. This is error messages, right? This is okay. So what do we mean by this? If we say this less than means that it's input, right? If we want to use that input file, if we want to reuse it, then you need to have this less than sign and %0. Less than, greater than sign and %1. What that means. I made here, we need something before we have this. History. I want to make this 982 once more. So 982. So 2 files created. Yeah, that is done. And if I want to report to, oh, but this is not input. If I want to report to the standard output, for example, not this. Input and output. I want to see input and output. I think 975 is better. So 975, which is I have an input files and also output files. Okay, input files and output files. If we want to see that input files, hey, I want to get that input files. Then you need to have the less than sign and ampersand 0. Although it is not very useful. It's not really. Read the input from file description 0, which means standard in. So I can put something here. And Control C. No, I think we need to skip this. This is not really useful here. Combine standard output and standard out into one file. Let's say this goes to, this is real good examples. Remember the previous ones, we put this, then this is a command, right? This command gives me the normal output and error outputs, right? True output and the error outputs. So true outputs can be written in this file, and error output can be written in that files. But somehow, if we want to attach this output, this is a error output. If I want to do, hey, I want to append the error output into this file also, then you can do ampersand and 1, then it goes into that. And therefore, cat files is not really append. It is enter into, right? The true outputs here and the error outputs back to this. So error outputs comes first. This is error outputs. And then true outputs here. So both together. That is, even if I don't do anything of this, then all goes into, right? See what happens. If I do this, then you know what? If I do this only, then only this true output goes into this. Error output, nowhere. So there's two ways. If you want to do error outputs into its own separate files, then you need to do number 2, and then you can do error.txt. You can do like this. Or the other way is file current file all.txt error. You want to save this. This is a normal output goes into this file, but you expect that there is an error, but you do not want to save that error as separate its own file. You want to attach that into that normal output also. So both together. In that case, you have to do this and ampersand 1, then it goes into together. Okay, so this error only, so 58 bytes. This is normal case, 87. This is all together, both this and that together. The size of this is not exactly the addition of those. Maybe it has some extra characters in it. 58 plus 87, then that is 145, right? 145 bytes, but it is 162 bytes, which means a little more than that. But anyway, that's how it works. So you can do like this, the standard output and standard error together. Then you can do this. Or another command, here command 1 and command 2. The same thing can be done here. You can do, for example, ls dot no nothing. You can make ampersand greater than sign. Then it goes into that output, right? You can make file all 2.txt. Then you will see here, right? This is make this. This comes from this output. What it means is that both together contains true case and the false cases, right? Error and true. So my question is, are they the same? They contain the same, the letter-wise, but the size-wise, they're not really the same, right? So if we do cat files or .txt, there's original ones, then I have that. But if I want to make a number 2, then you see here, text-wise, they are the same, right? Text-wise, they are the same. Only difference because it has new files here, right? Because this was not available before. But if I do redo that once, I think that'll be exactly the same ones. Like this, then it'll be the same ones. You see the difference? So now they are the same. Why? Because previously, when I make this file was not available. So there's a little bit difference. That one only the difference. Other than that, they are the same. To see they are the same or different, how can you compare them? You can compare them by having this size. Is there any way that any other commands that you can compare? There's another command called diff. Manual diff. Then you can see the difference. Compare files line by line. Okay. So diff these two files can be compared by using this command diff. This is the first file and this is the second file. If you compare that, then it gives me nothing. Why? If it gives me nothing, it means they are exactly the same. If we want to change a little bit, for example, And then if you do diff, then it gives me like this. This appears the end. I appended this, right? Appended this to the second file here. So this guy, this looks like a hexacode. Somehow this is a difference. The end, that much difference between these two. And this appears in, when you say here greater than sign, then this greater than sign is not the redirection. This tells you the end appears in the second. Like if there is a less than the left side or the right hand side. This means right hand side. So right hand side the file has this. If I add more, like the other, echo, and then we can say the first to the first file. And if you can see the difference, you can see both. The first in the left side, the end is the right hand side. That's what it is. Okay. Now I know what this means. This 10 is 10 lines. So first file, 10 lines. Second file, 11 lines. But this the end appears in the second file. That's what it is. If you see this output from this diff command, then both are 11 lines. And then this appears in the left side, left files. And this is in the right-hand side. That much difference, that's what it is. There's a new command for diff, as I said here. Compare the files line by line. So more accurate comparison, right? Rather than simply see the size of those two files. Do you got that? So I explained a little bit more than that. A little bit complicated, right? Redirection, less than sign or greater than sign. Therefore, you have an input redirection and output redirection. And then we have one more useful things that you can separate error files, and also you can combine error and normal case together in the one files, because if there is an error, then error goes error anyway generated, but greater than sign only saves normal cases. Therefore, you want to save it error cases in the separate files, or error case attached to the normal cases. Those two options possible. When you make it error cases and normal cases together, then again, there's two commands possible. You can make number 2 greater than sign and %1, then equals to the first files, or together % and greater than sign, then both regular case and error case into the same files. Okay, so two commands possible. So command 1 and command 2. So you can make some exercises. Putting them all together, create a file, numbers.txt, with those numbers, 1 per lines. So 9, Okay, generates a numbers sorted number and counts for each number. Don't copy and paste yet, but use a printf to create a file. And sort them are that. So can you do that? So 9, 3, 10, 3, 7, 9, one number per line. So you can use printf that I showed, right? And then sort Unix C. And then you have numbers underscore counts and numbers underscore sorted files, two different files to generate. Little bit of exercises. Anybody has done? By the way, Yandel, do you have a Raspberry Pi? Do you have a Raspberry Pi with you? What are you going to do? Do you have? You don't? I didn't bring it. I brought last week, but I didn't bring it this week.
I can pick it up next week. Thanks.
Or can you come
Or I
to
can
the Dobbsbury to pick up
when?
anytime? You need
Tomorrow?
to talk to. No, I'm not going to be. Yeah, tomorrow I'm going to be there, but
Or what time? Because I want to be in downstairs
tomorrow? What time?
in the morning.
Yeah, you can come.
So what room?
I'm going to be in 112 Mayor Hall. Do you know Mayor Hall?
Mayor Hall?
Yeah.
112. Yeah, I know.
I'm going to be there. My class from 10:20 to almost to 1 o'clock.
Oh yeah, I could be. So I'll pick it up tomorrow.
Yeah. What is it?
This is the form you gave us. Fill out.
Oh, club?
Yeah.
You want to play a club? Do you? Yeah. And also, can you fill out the other form to pick up sign up sheets? Oh, you don't have. Okay.
Yeah.
I'll give it to you. Use fill that out and bring it tomorrow so that I can. If you are there while I am there, I can get you one. Yeah, fill this out and come to me tomorrow. Paul, you have good news?
I think so, yeah.
Yeah, can you explain that?
Okay. So,
I'll type as you do.
okay, this is I didn't check this. but I think I got it right. I did print F. Six, yeah. For, print,
9
yeah,
backslash n.
/n 3 /
No, backslash n, not forward.
n 10 / n 3 / n 7 / n 9 / n.
Oops.
Yep, greater sign and numbers dot txt. You put print.
Let's see. There's something wrong.
Yeah.
Okay. 3.
It's the print part, the command part. You put print instead of print.
Oh. Bring. Back 7 and 9. 9 and backslash n. Backslash n. Okay.
Yeah.
So I can do numbers. Then 9, 9, 3, 10, 3, 7, 9. Okay. What is next?
Yeah, then I put sort
Sort
less than
less than
numbers dot txt. Then greater.
greater than.
Yeah. Then numbers underscore sorted dot txt. And then I did the unique C.
Let's see, numbers underscore sorted. You know what this happens? 10 is, this guy is not compared with the 10. This is a first character first. So 1, 3, 3, 7, 9, 9. And the next one is 0. The other one is spaces. So that's what it sorted. Okay, don't think this is number 10. By the way, when you make this, they're all string. So this is not number 10. This is 1, 0. Right. Okay, next one.
Yeah, so I put unique.
Okay, I want to make this. And after that, pipe.
Actually, I did the other thing. I did the unique -c.
Oh, you did the first?
Yeah.
Dash C.
Yeah. And then
You put.
I did the other way. I just did the unique C. Yeah, less than numbers dot txt. See, I didn't combine it. I didn't combine both of them. I did it like separate.
Wait a minute. How did you do that?
I did unique dash C less than numbers dot txt.
Okay. Numbers sorted, right?
See, yeah, I see. I did the that part correct. I should have typed it to combine it. I didn't combine it. I did it, but I see what you yeah.
So what do you want?
We could type it. We could do it.
Okay.
The number sorted in
And then pipe.
yeah.
Okay. Then you need to do cat numbers sorted.
Yeah.
And then pipe.
Mm-hmm.
Unique
C.
C
And then they take the output, right?
output.
Yeah.
And then numbers underscore counted.
Yeah.
.txt. And then cat numbers underscore counted. Then yeah, 2 3s and 2 9s. And these numbers, well, actually, those characters are sorted. Good. Any question about what he did? Okay. So this is a less than sign file. Then that is input comes from the existing files. And there is also double less than signs. You know the double greater than sign, then is append, single greater than sign, then that is output, right? Output and something append into it. In this case, less than sign and some word. Say you say name equals John, and then let's try as is. In the Linux command, you can declare any variables. When you declare variables, there is no the space between the equal signs, and then you can say Mercy. So name is Mercy. So next time if we want to see, then echo. If you say echo name, well, actually, echo is a little different. Let's see. When you say echo, then it's name, right? Echo and dollar name, then it is a Mercy. Dollar, then in Linux, it says this is not simply, when you say name, then that is, this echo takes this like a string. So when you do echo name, that is the same as echo name. But when you have dollar sign, this guy treat it as a variable. So look back if there is any variable called name, and bring the content of bring that the value associated with that variable will be returned. That is a Mercy here. Okay. So we have a name, and then cat. Cat usually, what is a cat? If you want to see the content of a file. But rather than giving files, I want to create just like a file. And then you can say until end of file or until anything. You can say up to this. And then you can say here name. And then if you want to say end of file, not really like this. If we say here cat and end of file, so this is the first line and second line. And when you say end of file, then this recognized as you declared, we want to put the files, that files increased, that files is available until you see EOF, whatever the value after this double less than signs. So here, but I said up to this instead of this well-known ones, whereas actually this end of file is well known to human, but this computer doesn't care, right? Whatever appears after this double less than sign, that is what the computer cares. So even if I say end of files, it means to me something, but not to this computer until it says up to this. When I say up to this, then that is end of that input files. So, and then that input files has this whole things, right? That is written, that is listed, cat command lists the content of the files, content of input files. But in this case, rather than giving input files, I want to make it from the terminals. So double less than sign, and then I have some token. Up to that token comes everything I want to concatenate them. That's what it is. So first one, hello John appears here. Second one, we are at $name. So we are at OK up to these points. Because there is a $, then it goes back to where that name declared. The name declared here, name equals Mercy. So instead of name as is, it returns what it contains, which is Mercy. And after that, EOF. Okay, EOF is nothing but hello here. And the next one is up to this. Now up to this. By the way, that is the token that I declared in this command. So cat less than up to this. So that is the end. So this is not included. This is simply a token. So all other 3 lines appeared here. All right? Okay. This is useful if you want to display, for example, real-time internet incoming messages. Okay, then it comes continually. So this is a summary. Less than sign, one single less than sign, then we have input files. Double less than signs, there is some tokens. Triple less than sign, there's a line of string into standard in. There's only one line, right? So I think WC, and then you can make a one line. I want to make a LC, WC, and option. Man, WC, C for bytes. I want to make a word. So make a word. How many words? Hello, how many words? This is not really. Oh, no such file was checked. Didn't work that way. Line of string is standard in. Hello takes, but not others. Line of string. Only one string. So it should be like this. If you want to make a string, then you need to make a string like this. If it is a one string, then I think it takes. Yeah. So everything is string, one line. and then says WC minus W. W means how many words, right? So we count words. 1, 2, 3, 4, 5, 6, 7. So it returns a sevens. The way that we can use is like this. This is also handy, right? Triple less than signs. Pipe. We looked at this so far a lot, right? For example, ls minus l, usr, bin, then you can see long list of the commands that we can use, right? How many of these lines? I do not know, right? If we want to see that page by page, then you can do less. Pipe. Everything here is the output of this, which is that we can see here, right? All of those will be the input to less. Less is a command that we can see page by page. So you can see first page start from this. This sign and there. And hit enter, 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 right? There's another command, the PS. PS is a process. So man PS, report and snapshot of the current processes. What is a process in operating system?
Something that's being computed.
It's a program that is running on your computer. What is a program? Program that you make. Yeah, you had some experience in Python coding, Java coding. Do you still learn Java, or you do, right? So whatever the files that you make, that is a program. If that is running on your computer, then that is a process. Okay. So command is nothing but process. Simply. So you see the process status. So there's some options. Lift the BSD style only yourself for restriction, which is A. I want to see AUX. And another X. X is a lift that is also similar to that A. You use a list selected by effective user IDs and names. So those are, so combine all of those. Say there is a PS and AUX. It gives you the list of the process, very useful process that you can see. This is run by root. Everything is run by root. And there is a process ID. At the same time, there is one process run by me, right? That process ID 3044, and some of the things. What process that I made? Just this itself command, PSAUX, right? There is another process that run by me, JUN. This is a process ID. And then bash. This is a shell that I made. How many shells that I have? I have another shell here, right? Which is, I have 2 shells here and there, right? 2 shells. And I also has LX terminal, right? And more. So long list. and pipe that into SSH. I want to grab. What is grab? Grab that you can see also man grab that you want to search some of the patterns. Okay, print lines that match patterns. That is what the grab is. So I want to print. It's nothing but print, and then pattern. I want to find out. I want to search SSH from where? From this input, ps.aux. That is what pipe can do, right? So out of this list all up here, if there is anything about that SSH. So I have some owned by root, SSH, some owned by me, and another owned by me, right? So what is SSH? SSH is a secure shell. So man SSH, then you can see open SSH remote login client. SSH is a program for logging into a remote machine for executing command on a remote machine. It is intended to provide a secure encrypted communication between two untrusted hosts over an insecure network. So even if over insecure network, if you use SSH, then that is encrypted communications. A little bit more secured. That's what it is. Here, ls-l and etc. It gives me a long list. So how many lines of those? Then you can see WC and -L. Then I can see, 234 lines, right? 234 files in that /etc files. Same thing if we want to see ls-l, usr, bin, how many commands stored in that folder, then you can see WC and -L, 2014 commands. 2014 commands are here, /usr/bin. Lots of commands already available on your Linux. Pipe, you similar thing this that we looked at, right? Sort and remote duplicates that we looked at that, and find the top largest items. Okay. DU. What is DU? I think there's disk usages. Man DU, then disk space usages, DU. Summarize device usages of the set of files. So you can make a multiple of those. DU -sh. So we may be able to see what that option means. So H is human readable, and small s is summarize. Okay, summarize of those. All right. So if I want to do DU -sh, then 48K. Let's make this on top. CD/, then I can go up to the top, right? Root. du minus sh, and then asterisk, then all the files, all the directories there. So I have, oh, this is too long. So I have here all the permission denies. If you want to avoid that permission denies, what you need to do? Sudo. So we can see these files 2.3, the /vir 2.3 gigabytes, USR 4.9 gigabytes, and temp files 72 kilobytes, and run proc. Let's see home. Home, I have 330 megabytes, etc 9.4 megabytes. This is the big ones, right? So I want to do and the sort minus h. What is a minus h? Sort. We can make man sort. There's option minus h for human readable sort. Okay. So this. Oops. I need to do. Okay, here. So this is because I sort it from the smaller ones to bigger ones. So you cannot access the process of that, no such file or directory. I have some of the error messages, right? So if you want to remove these error messages, then what you can do here, before you sort, number 2 and greater than sign, then it goes to the error message goes into, right? But that error messages that you do not want to display, then you need to go into some other device where there is null. It sounds like what? Because I have the /dev and /null.
Like a garbage can?
Yeah, you simply discard.
Right.
Okay. Unless otherwise that appears on your terminals, you want to discard it. So when you give a demo or a report to your supervisor, for example, okay? So your CEO and visit your workplace and then give me some demos of your monitoring systems. You know, there's some error messages that you expect. You do not want to give any bad impression to your stakeholders, right? All those stakeholders knows, oh, there's always error messages. If he comes from the computer science background, then he may understand. But usually CEO, no, right? And if they see some error messages, they think all of your work may be error. So, okay, then give it away. In that case, you have to number 2 greater than sign and the /dev /null, then it goes, it discard. See what happens. Very nice, right? No errors. Previously, although your CEO understands this, then, oh, that is normal. That makes sense. But usually, your CEO never makes sense. Right. Then you can use this. How can you get the top largest 10 largest ones? Then you can do here. I want to get from tail minus 10. So because this guy from this, right? Or you can do sort minus all. That's fine. Either sort minus all, and then you can get the head, or sort and you can get the tail. Either way, fine. In this case, top 10 list. I think if you want to show that to bigger ones first, then you better do, and then in reverse, and you want to make this head and hit enter. Nicer. Oh, this is what is your file systems? Or USR directory consumes the biggest ones, and the next one is the VAR, next one home, boost. Very nice, right? Question? Training Linux command. This is very, very important. If we want to, right now we did some of the tight linkages, tight couplings. So we have a pipe or greater than sign, less than sign. Sometimes you can do two commands, not really one to depend on another. There's no related, no nothing, but you simply two different commands or three different commands. You want to list of those commands in one line, not the one line at a time, but everything in one line, but they all do works. Then you can do semicolon. For example, date and the semicolon. And then you can do sudo this. And then you can do cat ls minus home tilde. They all works that way. Date, this is the date. And then next command, top 10 list. And next command, I want to see what files in my home directory. These are in my home directory. In that case, you need to do this semicolon. Make sure the semicolon before and after there should be space. Otherwise, they may be confused. Not all the time, but. So similarly, you have 2 ampersand and 2 pipe. I'll get back to you. That is that goes together. If you the run command 2 only command 1 succeeds. So this is make sure that's commands. This command's okay, and then next commands and next commands and next commands. If you want to make sure the first command that each commands successfully done, then you need to make a ampersand rather than semicolon. Semicolon doesn't matter. That independently. Double ampersand, then make sure the first one. If the first one has an error, stop there. If you don't care anything that goes, oh, this is this. If you have a multiple of a vertical, 2 pipes, then it means I want to make sure any one of these commands works. If first one is not working, then what about the second one? If the second one works, then stop there. Although we have many commands. Okay, this is more like or. This is like and. Or means from the beginning, if anything works, we stop there. And means I want to make sure everything works. If we want to make ampersand only, then it means I want to make it up in the background. Okay. This foreground and background, we will see this when we have a process. Okay, that comes next. Grouping. Two ways that you can group. Curly braces and parentheses. Curly braces, then current to shell group. You have a parenthesis, then sub-shell group. This doesn't make sense to you right now, right? It's not clear to you, but you will see what it is. This is very handy also. We are using the semicolon, right? So we can do, for example, CD TMP, then it goes to the temporary folder, and there I have ls list, and I want to see what is the current directory, and then another semicolon to end, and then end of that to group. Before I do, I want to go back to my home directory, cd home, and then sp26, and then my one is 9 March, right? 26. So pwd is this. Right now I am in /home/jun/sp and 9 March 26. That is currently where I am. And I want to make a group shell, but current shell group. So I want to shell, and the Linux command can be in a group, and that group of commands can be issued. So cd tmp, and I will make a ls, and then pwd, and they're all together. Okay, so this one command, this is another command, this is another command, but in this order. And I group them within that curly braces. I did that, right? So cd tmp, it goes into that the tmp. So what is the tmp? /tmp. If you see here, cd goes on top where there is a tmp. Where's the tmp? Yeah, this is the tmp, right? TMP is a folder. So if I do cd tmp ls, those are available in that temporary files. That's what I had here, right? I said that cd tmp, and next command is ls, so they did list ls. And then I said, what is the current directory? That is a /tmp. And then /tmp. And then what is my directory? /tmp. Right? Where I make this command? I commanded that in this directory. My home directory, sp26, March 9th. This is the directory where I issued this command. After this command, because inside there is a cd tmp, after this command, now I am there. That is current shell group. Everything here affects my shell. Therefore, my directory now /tmp. Okay, that is not the same as this. I want to change directory to my home directory. This is where I am, right? I want to do this exact same thing. Copy and paste. Only difference here is instead of that curly braces, I want to put there parentheses. Okay. Do you see here? This is the exact same ones here and there, right? Except the container. Container here, curly brace. We call that current shell group. This is a parenthesis, so we call that subshell group. When we have subshell group, change directory inside this subshell group, would it affect to my current shell, or it affects only within that subshell? That's what I want to show. Previously, after this, because this change directory affect to me, therefore finally I am /tmp. But in this case, as I try to explain, you may think it should not, right? Even if inside here I change the directory to tmp, because I am here outside still remains the same. Everything here is a sub. It doesn't affect me. Global. That is only local. See what happens. It returns the same thing here. tmp. Where I am now. I am okay, right? Do you see? Here, I was there within this curly braces because this affects me. At the end of this, I am affected.
Like you move with the command, the first one,
Mm-hmm.
and the second one, it does a command, but you don't move with it.
Right. I'll let you do. Don't affect me.
Right.
So you may be able to see, oh, yeah, both can be useful for some cases, right? But I want you to understand what is what. That type of things is very good type of questions for your midterm exam, right? I may be able to see this is issued. Where are you going to be at? I want to make this screenshots. Okay. So everything is, I explained that. Here, oh, this is another interesting thing is this. X is 42. Well, X is 100. So now X is 100. And I made X is 42 and then echo. Inside the X is $X, and then that is the end of that. So X is originally I said the 100. Inside of this curly brace shell group, I have X equals 42. What happens if I do X equal 42? That is replaced, right? Because this affects me, right? It says index X equal 42, X equals and $X, then that is evaluated, right? So instead of X, it says 42. So X equal 42. So when I come here, echo, and then $X, then it'll be 100 or 42?
42.
42. Here you go, right? Again, I do X equals 100, and I will do the same thing, but here. And when I do echo X, what is?
100.
100. You're right. Very nice, right? So this is another thing that I want to save. Okay. Shell and subshell. We did that. This is a little different. If we want to see echo, $X, that's fine, right? But if we want to do echo, say Y equals 3. If we do Y equals 3, then it's not going to be. You have to do, there's no space. Then we have echo $X and $Y. Then we know 100 and the other one is 3, right? Is there any way that I can do some of the computations? For example, $X times $Y. It doesn't recognize, right? Right. So if you want to compute, then you need to put here dollar double parenthesis, then it'll compute 300. Here, symbol dollar double parenthesis, that is called arithmetic expansion. So you have to do dollar double parenthesis. So this is a comparison. I already compared those two things. So this and that we already did. Okay, file management. So we did so many interesting commands so far, and now we'll look at so file management. What can we do? We can do file archiving. If we have an archive, then we can do extract it, and if we have two files together, then we can do cat of two files, and then this is output redirection. In that way, that can be combined together. Same thing, you can append that too further. So many files can be put together, or you can append. So let's do this first, and then we'll come back here and then compress. Okay. Let's see, cat etc password. It gives me the password files. These are the password files. Let's see here, Jayun colon, and then that is X. X is originally, this is my login name followed by my password. My password is hidden. It should not, right? When I was a student, long time ago, century ago, their password appears here, not hidden like this. Here all the password X.
It wasn't encrypted.
It is encrypted, but if I copy and paste, that goes into. Okay, at that time. So for example, I was hacked in Carnegie Mellon University Andrews server. Very simply, because I can copy and paste the password into it. Right? That's a take case of it. So Carnegie Mellon University is filed that to FBI. So FBI came to me. But I was okay. Why? It's there. Did I violate it? No, it is there, right? You didn't hide it, so I can use it. Since then, they put their X mark. This is true. I'm not saying false story. This is true. I did that.
Yeah.
So we talked to the FBI. At that time, FBI's investigators do not know. They know nothing. So I explained that. Hey, this is public. This is shown. Why this is public? By the way, password files. There's no permission, right? Password file itself should be public. If it is private, then no one can get in. Your operating systems may not be able to see you are there. Here, Jayun is, because I can open it, I can show, hey, I am there. Exactly the way that operating system works. So it should be open. Password file should be open. The problem there, once it is open, if there is a password also, then that is the problem. That is insecure, right? That is the security holes. That is the vulnerabilities. Since then, they pull all the password files into another files. Like the one that we did, if there is an error and the normal cases, then normal case into normal file and error case into error files. So password files into password files, another files. We'll get to that later. Okay. So now that is a long file. Another file here is /etc and /group. This is a group. After that password, so this is login name, password, and after that, this is a user ID 1000. Next one is a group ID. So right now, user ID and group ID are identical. I didn't make any group yet, but you may be able to see some of the groups here. I'm not sure. 100. But you can make a group. But right now it is not a group, right? So if you see the cat, then you see the groups. Jaeyun group is 1,000. There are many others also. Many of them are not really the user, right? Some of the process. So I want to make them, I want to make password etc group. What happens? Then I made all in one standard output, right? So that I can put that in a file. So I can make all.txt, all password.txt. Then I have that, right? All that pass.txt. I can put there more. For example, cat, etc, and host. Then I may be able to see here 127.0.0, 0.0.1, then that is the local host. This is a Raspberry Pi. So this is a loop back IP. This is my. If you say local host, then there is nothing but 127.0.0.1. That is host. We can do this also append to that all pass.txt. Right now we have 3415 bytes long. After we appended that, then 3547 increases. That's fine. So we can do this concatenating and appending. Archiving. What is archiving? If you want to save it and then keep it, then you can archive it. That's what archive means, right? There is a tar command. What is tar? Tar is tape archiving. Okay, tape archiving. So man tar, then you can see arbitrary on archiving utilities. Tar is archiving utilities, but on tape. So tar means tape archive. Okay, there is an option VCF. There is a command C. There's archive. Command X. That is for extraction. So we want to practice that. Okay, so we do tar. V for verbal. So you can see all the steps of archiving files. And then C for the archive, F for files. So we can make a archive dot tar. Tar is the archive file formats. And then I can make all files star. Okay. Currently, this is my files, right? I want to archive all of those files into this file name, archive.tar. Hit enter, then because I put here V, I can see the verbal and then archive and files. If I don't have, for example, V here, only CV, then I don't see those, simply hidden. Because it is already there, I want to remove archive files, and then if I want to do this, then see difference here. If I don't have a V, then I don't see any. I do not know what kind of files are being archived. I can hide it if I don't have a V, but here I can see it. Then I can see the files. I have archive files. This is the size of that. Everything there. Then I can do. The beauty of this archive is all the structures can be also completely archived. After that, I can zip it. There are many compress commands available. Let's see if there is a compress. There's no compress, but gzip is available. So man gzip. It is gunzip. So compress and expand the files. There's a gzip. Gzip. There's an option.
It doesn't matter how we organize the options, right? Like if you were to write
minus, you mean the order?
Mhm.
No matter. Yeah, you can combine anything. For example, ls minus l a, ls minus la, or ls al.
It's gonna be the same.
Doesn't matter. Yeah.
Okay.
Gzip C, then write out the standard output. Minus gzip minus C, that's a standard output. It is a standard output. So you have to, if you don't do anything, that it returns standard output means that there's a terminals. So you need to make a output redirection. That's for C. There's a zip. Anyway, this is compressions. If you want to unzip, then you need to G unzip. G zip or G unzip. Okay. So if you want to make this G compress, then G zip, and then archive into TAR, and then you can say compress, maybe zip. Then it can be compressed. Oh, although I don't do anything, it is already have a gzip. So this is nothing, right? We do not need to. So sometimes you may receive the files when you install it. You may have tar.gzip files. When you receive this kind of files to install, then you need to first g unzip and then untar. To make an untar, then there is the same command, tar, but there is an option X for extract. So I can send this to, for example, make another file, another directory. So mkdir, and then I make a temp directory. So I have here temp directory. I want to send this to archive files to temp, then goes into that temp file where I am right now. I'm in home/chapter jun/sp26/9 March 26/tmp. So I'm inside the tmp files because I copied it already. So I have archive tar.gzip. What I'm trying to do here, under that, I want to untar that archive files to see if I have all of these files into that subdirectory, tmp. In order to do that, I need to first do gunzip and then archive gzip. Then it can be untar. Previously, I have gzip. Now, because I do gunzip, now .gz disappeared, but I have only tar files, archive tar. What is the next step? That I need to tar and minus xbf and then archive tar. Hit enter. Right now, because I have here verbals, I can see which files are to be extracted. List of all. So those are the extracted. So when I do ls, I have all of those, right? As if I have ls ... What's the ... My parents. So I can see parents. My parents has those files where I have archive and zip files. I copied into this tmp. So I am this inside the tmp. I untar so that I have those files that I have, right? There's a tar and untar. So files can be manipulated that ways. So once you have a files, that can be archived for your safety, for your record, okay?
Archiving is kind of like compressing in its own right?
In this case, collect all and compress, and then save at the safe place with no internet connections. Then it real safe. If it is archive, when you have so usually what you do is you archive, for example, each every month, and then store that one copy here in Manhattan, another copy usually in New Jersey, Parsippany. Usually there are lots of archive servers there.
Yes.
And then if something happens, then bring that copy here and then untar, uncompress, and untar, then you can get the previous version of your file systems. Environmental variables, you can see all the print env, that is a command. Man print env. So print all or part of environment. Okay. So if you do print env, then those are all the variables that already set. Path. What is my path? Then /usr space /usr /local /bin : So this is available to everybody. This is available to everybody. This is available to everybody. That type of things. What is the user? jun. Therefore, for example, if I do Yeah. Just like as I said here, some of those things you can do print env and then user/user. Then you can see that using this command, whatever the environment variable that you set, those are the environment variables, right? Then you can get it. Using this print env command, if you want to use echo command, then you need to have $sign. Because USER is not understandable by echo. It is understandable only because this print env is the command for this list. So print env knows user file. Print env knows path. So we can see the path. But if you want to do echo, then echo does not know path. Path is maybe. Path is well known. See what happens. Not, right? So you need to have $path. If we want to make that environmental variable, then you need to use the export. For example, print env. See what do we have? Those are the all print. This is a color. Color can be defined in this way. Home, that is home. All the environmental variables. So shell, there's /bin/bash. As you see here, these definitions of that, the equal sign before and after, there is no space. Okay, that is the way that you can define in the Linux operating systems. So for example, Python command that it gives you 3.11.2. But if you want to make Py for Python, then you can define that way. And if you do .py, then you can run. If we want to export that, py, and then print env, then you can see that py, right now I do not know, it has py. Yes, it's defined, right? Print env, and I said grep py. So py is defined as Python. So you can do simply py. So there's a variables. Local shell variables and environmental variables. Between local and, if you have a local shell variables, if you have a global, then you need to do export. Then it goes into the global environmental variables. Okay, this is the end. Okay, this is all I prepared for today's class. Anybody has any question? Abdul, how are you? I told you, Abdul. Julie, how are you? Okay. Are you ready to do homework? I'm thinking of what kind of homework that I want to give it to you. Maybe it's something interesting things. Chris, I'm glad that you have HDMI cables that fit into. So there is one side the micro, the other side the mini.
Yeah.
Nice. Aaron, did you get? Good. All right. This is it for today. So I will see you next week. And 2 weeks from today will be your spring break. So no class 2 weeks from today. So next week, please come next week because that'll be the last lecture before you have your midterm exam. Of course, we will have review sessions during spring break, which is 2 weeks from today, the Monday evening, so that I can bring the face-to-face class and then online class all together in one session. So we'll do some of the reviews. Okay?
Review questions like questions and answers, or is it pretty much like coding like that?
No codings, no computers, only paper and pencil test. Okay. All right. See you next week.